Hi, everybody. In this tutorial, I'm going to give you a quick introduction to how to create a project in C.Scale. C.Scale is a whole life carbon tool that's designed to support climate positive design decisions across building design and delivery life cycle, especially in the early stages of a design project when you can have high impact for your initial strokes of the pen, as it were. So I'm going to jump in. What you see here is when you log into C.Scale, you're going to see your portfolio. And in my case here, I don't actually have any projects started yet. So I'm going to do that now. Over the course of time, as you start to build a portfolio, you can start to create collections within here. It can put you in a position to assess the carbon impacts of your projects across an entire collection, across an entire portfolio. So there's some utility there. I'm going to start a new project, and you'll initially get this menu, create a project, and I would recommend developing some kind of method to index your projects based on project number and name. But I will say here, I will input something generic. I'll say example office building, project number. I'll just say for now 26001. And you get this option about if you want to design with a construction type set to new construction or reuse and retrofit. So this right off the bat underscores a very basic principle with designing for low carbon architecture, which is the lowest carbon solution would be a reuse and retrofit, sparing the need to create a structure, an enclosure, etc. So adaptive reuse project, retrofit projects, these are going to be the best options in terms of low carbon, but I'm going to start with the new construction here by way of example. And the next you need to set up the year that your project will be completed. I'm going to say 2028. An address, I will give it an address for Indianapolis. Okay, I'll hit go. And you see the wizard go to Indianapolis. Okay, that looks good. I will hit next. And so then here we have a menu where we can start to choose the primary use. And when you select this, you'll see a range of project types. And you can see that there's an office listed here. But I just observe for a second the many different project types, each with their own default assumed uh, profile to them. So choose wisely. I'm going to pick office. You can decide if you want imperial units or metric. I'll stick with imperial. Number of above ground floors. I'm going to assume a 5-story office building. Total construction. I am going to get a calculator here. I'm going to assume, uh, let's say, 3 structural bays by 3 structural bays. Let's assume they're 30-foot bays. So 90 times 90. That's going to be 8,100 square feet, generally speaking, times 5 floors. That is going to be total constructed floor area above the ground of 40,500. Okay, I'll hit next. And scope settings. Perhaps under your account, you may have some firm-wide or company-wide standards. I'm just going to hit custom here. And you can see that I get to choose an analysis period. So depending on what framework you're designed toward, if you are designed to a framework, say LEED, they may ask for a 25 or 30-year analysis period. Maybe you're working with a framework where you want to look at 60 years. I'm going to assume 30 for this exercise. All categories, you need to pay attention to whatever framework you're adhering to. Are they asking for a specific scope? Maybe just the structure and closure, maybe structure and closure and interiors, or maybe all categories. I'll pick all. Auto-generated decarbonization scenarios. You may have, again, a firm-wide or company-wide standard. C.Scale has some built-in standard scenarios. I'm going to hit none for this exercise. I'm going to hit create. And so It is now creating my project. You can see here this 30-year life cycle assessment. You can see immediately in the middle here with this figure, a number of colors, each representing different ways in which your building is uh, contributing carbon emissions. And this is cumulative. So what happens in year one? You're going to have a lot of embodied carbon emissions as the building was constructed. You're not going to have very many emissions from electricity or on-site combustion, but over the course of time, this is cumulative. You can see how this will increase. And so it is additive, it is cumulative. And if you were to hit annual up here at this dial, now you can see a different set. So this is not cumulative. This is just looking year after year. So here you can start to see some of the built-in assumptions that over a mid-span of this 30-year life cycle, we're going to assume some uh, improvements that's going to result in some construction and some expended embodied carbon emissions. This is going to happen again in year 30. But you can see also how the electric emissions. So let's look at these colors here. This really dark blue, this would be on-site combustion. So it's assuming that the building is using natural gas. It's got electricity-based emissions. I cited this project in Indianapolis, so this is based on current projections for the resource mix, the fuel resource mix that is being used at the utility scale and how this can change over time. And then this light blue up here is refrigerant emissions. You may hear this referred to as fugitive emissions. They do count, they do add up. How much do they add up? You can look over here at cumulative and you can see it's not an insignificant piece. Notice up here too, I have this set to kilograms of CO2 equivalent per square meter. You can also set the total carbon emissions and take a look at that. So these dials allow you to assess and different graphic outputs. Okay, so on the right-hand side, we see business as usual, the BAU case, the baseline. It's orange. It's orange so that you will, as you start to build up different scenarios here in the lower left, you might lose track of editing your baseline. This is just a way of visually warning you, hey, this is your baseline. This is what everything's comparing against. So I'm going to open this up, go to form and massing. I'm just going to quickly give you a preview of each one of these. So building perimeter, 360 linear feet, floor to floor height. I'm going to actually tweak this. I'm going to assume 14-foot floor to floor heights, window to wall ratio, 45% is a bit high. I'm going to assume 40. Okay, and then I'm going to go down to energy use, and it's going to give you a default EUI number. Maybe you have modeled and have a different uh, idea of what your predicted energy use intensity could be. Maybe it's lower than 93. That's fairly average for an office building in Indianapolis. I'm going to keep it there. I notice here I can dial up all electric. So if my building is all electric, I can click this, but I'm going to assume for now it is not. I'm going to assume that I am using some on-site combustion for 20% of the energy use of the project. Clean power purchase, I'm going to assume 0% at this time. On-site photovoltaics, I'm going to assume none at this time. Again, this is my baseline. Structure, I'm going to assume reinforced concrete, that this is a completely new construction project. There is 0% reuse. I am going to leave reinforced concrete as the primary that will default there for secondary. Structural efficiency average, live loads 100 PSF. I'm going to leave all of that in place. I'm going to go to my enclosure and notice it has solid exterior wall, transparent exterior wall, and then roofing down here. So for our solid exterior wall, reuse 0%, cladding type. You get a limited number of options here. I'm going to assume thin brick masonry veneer. And notice that immediately changes my 30-year cumulative projection and service life of that exterior wall, 30 years. Notice you can dial this differently for some components of your project, differently than the life cycle assessment of 30 years that's being depicted here graphically. Transparent exterior wall, That would be your glazed components. I'm going to assume the primary structural system type is a curtain wall system and 30 years for that. My A1 to A3 values set there. Okay, roofing, 0% reuse. I'm going to go with let's say a PVC membrane, and notice it immediately updates that. 30-year life. Interiors, 0% reuse. Floor area with fit out, 70%. That's not going to be completely fit out. Carbon intensity, average. Services, this would be your mechanical, electrical, and plumbing services. It's all going to be new construction. 100% of the floor area will be air conditioned, and the carbon intensity will be average. Refrigerants, a total refrigerant charge, high carbon, refrigerant global warming potential, high carbon. Going to leave those in as the defaults here. Site work, edit site work parameter, enter a site area in all project settings. Okay, so I don't have my site activated yet. I can go over here to the left to this project settings, this gear icon, and I can, by the way, go back and change some of the things I input for the project to begin with. But you see here immediately, for instance, I could change my analysis period from 30 years to 60 years. The life cycle stages, what is this about? This has to do with the widely accepted international standard for life cycle stages. I've got these graphically depicted here. So when you see product stage A1 to A3, this would be those. Construction stage A4 to A5, that would be here. And then the actual use stage of the building, end of life, C1 to C4, and then circular economy beyond the building life cycle stages. If you can reuse it, recover it, recycle it, then you may be able to utilize D here. So that's what these are in reference to. So that's what all of this means. Notice A5 would be construction related emissions. So for A5, that would be right here, construction and installation process. And operational is B6. We input that EUI up there a while ago. And that would be, actually, if I go over here, listed there, operational energy. Okay, that'll be in there automatically, as will A1 to A3. My categories listed here, you can dial some of those on and off depending on what the scope is. So categories, this would be the scope, and you can share your project. Here's some general information. You saw me input this earlier. Location, you saw this earlier. Use type, office. I can also add a secondary use. Building size, we did this earlier. Now you can come in here and add below ground floors, but then we get to this next one, site work. Total site area. Well, if my single floor plate was 8,100, let's assume perhaps an 11,000 square foot site area, and let's assume that it's going to be in a greenfield. Okay, electric grid, mid-case decarbonization, you can dial this up or down as you may see fit. Emission metric, you can again dial this as you see fit for your project. Energy benchmarks, you can adjust this if you want. The benchmark EUI listed here, energy code listed here. We're in 90.1 2007, so I can put that in. And that's probably a more accurate baseline considering in Indiana, that's currently what our energy code is based on. Refrigerants, leakage rates based on lead. You can adjust this as you see fit. I'm going to leave that in there. So that was a really long-winded way of showing you how we add the site. But along the way, you also got familiar with the project settings and saw some of the other things of which it did tweak some of these numbers. So under site work now, planted area, let's assume, maybe 10% of the site is planted. And we'll leave the rest of this as is. And we go down here to the last menu item, construction type. And this is going to be, as you see here, include the demolition of pre-existing buildings if it applies, and construction activities, A5.2. And so this is looking at A5. This is, to go back to the figure here, this is looking at A5. So it's showing you what 5.1, 5.2, and 5.3 would be considered, and it's giving you a construction activities number here on a CO2 equivalent emissions in kilograms and a per square foot basis. I don't love that. I wish that was per meter, but be that as it were. Just make sure you're always mindful of your units. Everybody, there we got up here. This is kilograms of CO2 equivalent per square meter. Down here, we have kilograms of CO2 per square foot. So just be careful. Okay, so this is total CO2 equivalent emissions, and now we have it set for our building. We have our baseline scenario in place. You can see up here this 54th percentile, and our baseline is now set, everybody. I'm going to add a new scenario, and the way I'm going to do it, I could go here and I can set the name. What I'm going to do is actually hit these three dots, and I'm going to say duplicate. It's going to be our BAU copy. I'm going to go here again. I'm going to rename this. I'm going to call this option 1, building reuse, plus all electric, plus I'm going to say plus PV. Okay, so I'm going to do three basic things here. I'm going to assume that maybe I've convinced my client, my project team, I'm not going to build new construction. Maybe we find an appropriately sized, identically sized as it would be in this example, this theoretical example, a building that's getting reused. So structure, I'm going to say reuse for the structure, 100%. Okay, that's immediately adjusting my assessment here. Reinforced concrete, I'll assume that. Okay, enclosure, let's assume that we're gonna have to redo some of the enclosure, but let's say that 90% of it is going to be reused. And on my transparent exterior wall, I'm gonna say we're gonna re-glaze the entire thing, so that's not getting saved. And we're going to re-roof it as well. Okay, so then I'm gonna go up here to energy use, and I'm gonna hit all electric. So now that combustion piece went away. Clean power purchase, let's say that 25% is a clean power purchase, and I am going to have on-site solar. And let's say my project team had a target of 20% of PV. I input 20%, and immediately it gives me my nameplate capacity, 166 kilowatt array area, 13,579. Now that's a problem because, as mentioned earlier, if I have a 90-foot by 90-foot building footprint, that means I only have at the absolute most 8,100 square feet. But you know you're not going to be able to use all of that. If I'm just reasonably conservative with those estimates, I would say I'll be lucky if I get 8,000. So I can change this to 8,000 for my array area on my roof, and it will go through and do these calculations. Notice it immediately changed these other two inputs. It made it a 98 kW system that only takes 12% of the electric load. So in real time, it switched that up. And now I've accomplished what I meant to here. Option 1, building reuse, check. All electric, check. PV, check. So how does this compare to our baseline? I can go to compare scenario and get a figure that looks like this. You can see year to year, our business as usual, and option 1 as this darker line that's running through here. I can look at the life cycle emissions like this. I can show the reductions in this manner. That's going to give me a graphic representation of how much we reduced. It's a 31% deduction in the 30-year accumulative carbon that I would get. Notice some of the things that are markedly different. This is presuming long-term projections for the grid and what's going to happen to my on my all electric scenario and the drop in the energy use based emissions, but also this red for structure because I'm using an existing building. That is missing here now. That's gone. I have eliminated that source. You can see the other categories noted. You can go to the summary, get some information that way. So this is interesting. Let's make one more scenario. I'm going to say let's actually duplicate our baseline again. We will rename this. Let's say this is option 2, mass timber plus all electric plus PV. So I'm going to do the same thing again here very quickly. I'm going to assume an all electric building. I'm going to say a 25% carbon purchase. That is what I had here. If you need to go back and check, you can just click over. Yes, that's correct. Click back over. Yes. Okay. And then PV. I'm going to say it was a 8,000 square foot system. And you'll notice this will dial right back to what we had before. Okay. So now I'm going to go down here to my solid exterior wall. Let me remind myself, option 1, that was 90%. So I'm going to go back over to option 2 and set this to 90%. And then, so we have that finished. I need to look at my structure because in this scenario, we're looking at mass timber. So we are not going to reuse. I'm going to say primary mass timber. I'll select that. And down here, this does matter. If you've researched mass timber, understanding these responsibly sourced timber attributes they do add up, they do matter. Transparent and traceable supply chain, let's say yes. Source forest has a growing carbon stock, yes. And then timber is certified, recycled, or reclaimed. Let's say yes for the purposes of this exercise. And so I click all those down. I look at option 2. Notice it's only a 27% reduction from my baseline, whereas option 1 is a 31% reduction. So the building reuse it performs better in terms of carbon emissions. We've reduced by 31% compared to 27. But wait, there's more. If I look at this option 2, I go to this scenario and I click back over, notice here's my 0. These are cumulative emissions. This white is showing you how much less it is than the baseline. So that's good. That's showing you these reductions. But what's this green down here? This is stored carbon. This is negative 797 kilograms of CO2 equivalent per square meter that you achieve by using mass timber. You're getting stored carbon, which is significant. If I were to look at compare scenarios, you can see again all 3 of them. If I were to look at life cycle emissions, the summary. So I go to summary. This is total emissions now. So we're looking at the total emissions over 30 years. And this is the graphic out of the 3 up here at the top that we can actually see the deficit, the reduction of 798 kilograms of CO2 equivalent per square meter for option 2. So if we look at just the emissions that the building gives off over the course of 30 years, you would say that option 1 is slightly better than option 2. But when we look at the stored carbon cumulatively over 30 years, we can see that option 2 is actually the preferred option out of them. Also, if you close out the scenario menu options over here, you can get in a snapshot the difference between whatever your active scenario is and the baseline. But through this will give you a quick start into C.Scale, and hope you get acquainted with this online platform very quickly. I hope this has been a helpful tutorial and will demystify C.Scale and help you get a quick access and kind of a quick start to a pretty amazing tool. All right, thanks everybody.